Great. Well, hello everyone and welcome back to Inclusive Design 24, 2020. I'm Thomas Logan from Equal Entry, and I'm coming to you today from Tokyo, Japan. Very honored to be a host for this excellent event that's happening for 24 hours today. We want to first acknowledge and thank our sponsors that helped make this event possible. So we want to thank our platinum sponsors, who are Barclays Access and Adobe. Our gold sponsors, who are Intopia, Tetralogical, and InfoAxia, and our silver sponsors, who are Intuit and Webable. So thank you to all those sponsors. They're helping us put this event on and make sure that we have an accessible event for everyone. We want to let you know you can follow along with the rest of this conference, or if you are just joining us now for the conference, there is ID24CONF on Twitter. That's our Twitter handle. And if you have questions or you want to participate in asking our presenter for this hour questions, you can use the hashtag ID24 on Twitter to ask a question, and we'll be monitoring that during the presentation, and we will ask those at the end of the presentation. We want to remind everyone that we are a respectful community, and you can see our code of conduct on the website. We encourage everyone to be inclusive, make sure that we share questions and ask questions in a way that can be made available for everyone. And with that, I'm very happy to introduce Jian Wild, the owner and CEO of Accessibility Oz, to talk about this very important topic of mobile accessibility. So take it away, Jian.
Thanks, Thomas. And I had no idea that you're in Tokyo. I'm currently on the Sunshine Coast in Queensland. It's beautiful here. We're coming into summer, which is good. Thank you so much for having me. And thanks to the sponsors. Today, I'm going to talk about mobile accessibility. So the first thing I want to start with is mobile accessibility fails, the good, the bad, and the ugly. And so basically, I've run a session very similar to this for the last 6 years about all the crazy accessibility fails and usability fails that you can see in mobile. And here are just some of them. This is Jamie Oliver's native app, recipe native app. And when you first open the app, it throws you into the video player on your mobile device. And this is a violation of WCAG 2 Success Criterion 2.2.2 pause, stop, hide. This here is an example of Amazon. And of course, what do you do when you go to Amazon? You're looking to search. And the what are you looking for, or the search bar, is grey text on a white background. So very difficult to read and fails WCAG 2 Success Criterion 1.4.3 contrast minimum. This here is an example of Netflix. I do a lot of travel, I did before COVID, and occasionally I would get this error on Netflix that was called error, and that was it. And this fails WCAG 2 Success Criterion 3.3.1 error identification and 3.3.3 error suggestion. This is ABC, the Australian Broadcasting Corporation, and on the left they have, this is their native app, they have an article with its absolute smallest text, which is about 6 points, and on their right is the absolute largest text that you can get in the app, which is about, say, 12 points. And that doesn't actually meet the WCAG 2 200% because the standard text is about 10 points, so it doesn't increase by 200%. So that fails the WCAG 2 Success Criterion 1.4.4 resize text. But the important thing to note is that if you scroll to the top of the screen, if you're using the small text or the large text, the top of the screen, which has the article title, etc., is all the same size, whether it's small text or large text. So the article title is the same size, the date, the time, the caption, and who wrote the article. So it's not consistent. So basically, we developed a mobile testing methodology, one for mobile site and one for native app, and I'll talk about who we are in a moment. Basically, what happened is there's a conference that occurs in October, September or October, every year called the ICT Accessibility Testing Symposium. And during that conference at the end, there's often a town hall. And this conference is aimed at accessibility testers. It's an excellent conference if you're an accessibility tester. And at the town hall at the end, as an industry, we get together and talk about what is it that the industry is missing or what does it need. And so in the 2017 town hall, we discussed how we really needed a standardised mobile testing methodology. We were aware that WCAG 2.1 would be released in 2018 at some stage. So we thought that this would be a short-term thing, but we wanted something that the accessibility companies around the world could agree on. And so I was co-chair of the 2017 or the 2018 committee, and we came up with a set of guidelines. Now, the guidelines that we released in 2018 were mobile site and native app together, and we learnt very quickly that that wasn't going to work. So what about WCAG 2.1? Yes, it got released in June 2018, but we found that and just to step back about why WCAG 2 doesn't apply to mobile. Everything that's in WCAG 2 you can test on mobile, but it really does miss some major mobile accessibility requirements. So for example, WCAG 2 requires that sites be accessible to the keyboard user, but it doesn't specify that it should also be accessible to the touchscreen user. And this is one of the things that WCAG 2.1 did address. So WCAG 2.1 builds on this, talks about things like pointer gestures, sensors, and small screen devices. However, as a committee, we really felt that it didn't go far enough. And one of the reasons is the pointer gesture, touch target size requirement, which requires that an item has a specific touch target size on a mobile device. That is in WCAG 2.1, but it's at the AAA level, which, as you know, mostly means that it gets ignored. So at the end of 2018, we convened two more committees for 2019, one to develop mobile site testing guidelines and one to develop native app testing guidelines, and they were released at the end of last year. So why is mobile different to desktop? Firstly, desktop has a whole bunch of different screen readers. People can build their own screen reader, whereas mobile, you're restricted to what comes inherent in the actual device. So you're talking about native screen readers such as TalkBack on Android, Narrator on Windows for anyone who has a Windows phone, VoiceOver on iOS, and of course there are things like Voice Assistant on Samsung, but there's really not much more than that. There's, of course, volume control, vibrational keyboards, visual, auditory, vibrational notifications, text-to-speech, speech recognition, Zoom and dark mode and things like that in iOS 13. There's also system accessibility settings that are quite different to what you would experience on desktop. Font size often operates very different to desktop in terms of the increase using the two-finger touch, touch and hold delay, screen rotation. We're very used to seeing things on a desktop in a kind of a horizontal rectangular display, but on mobile, most of the times the display is vertical, rectangle. And you see that, of course, when you watch videos that have been videoed on a mobile and then played on a desktop. There's a whole lot of dead space. Then there's things like assistive touch and mono audio. One of the things that I want to mention is page variations. So the problem with mobile, one of the problems with mobile is that it kind of falls into this page variations requirement. So often what you see on a desktop is completely different to what you see on a mobile, and it's basically the same page, but there's two different variations of a page. And often these variations or these mobile views can be triggered on the desktop by increasing text size. Most of the time, a variation is triggered by screen size, and so if you increase text size, it actually mimics the small smaller screen size. And as a result, you can end up being restricted to a mobile view of a site on the desktop. So for example, previously in YouTube, they have fixed this. They upload a notifications button, were available at 100% screen size. But if you increase the screen size on your desktop to 200%, that they would disappear. And that would mean that people who had to increase their screen size or the text size because of low vision wouldn't actually be able to upload videos on desktop. So this is what the desktop looks like at 100% text size. Your upload notifications are in the top right-hand corner. And when it's at 200%, they disappear. And why do they disappear? Because it's assumed that you'd be looking at this on a mobile device. And therefore, if you were going to upload videos, you would use the YouTube mobile app. But of course, if you're on a desktop and you're in low vision, then you don't have that opportunity. The other thing is that 2.1 stresses accessibility supported, which was required in 2.0, but basically it says that whatever techniques that a technology has that assists accessibility need to be used. So basically, when it comes to things like native apps, what this means is that you really must be testing with assistive technologies because there's no actual access to the code like there is with a mobile site. So it's much more important that you do testing with assistive technology. And I'm a big believer in making sure that assistive technology testing is done by people with disabilities who are reliant on those assistive technologies. So because we didn't want to spend 10 years writing it, and one of the things we really wanted to do when it came to this methodology is make sure that it iterated quickly, is we didn't include things that are in WCAG 2. So for example, images requiring alt attributes are not included in this methodology because that's a WCAG 2 requirement. However, things that were added in 2.1 have been added to the methodology. It's very clear when something is also a WCAG 2.1 requirement, but we didn't want to have people that were required to be WCAG 2 compliant and wanted to make their mobile accessible, then, miss the 2.1 stuff that was in there. If there's one thing you take away from this course, it is to test with real devices. So about 6 years, I've always travelled for work, but about 6 years ago, I started travelling to the US for work. And it's a 15-hour flight, if you're lucky, 15 and a half if you're not lucky, from Australia to the US. And this was before you get Wi-Fi on aeroplanes. And so it would often be quite a struggle for me to be awake that long and not on the internet. It's amazing how much you use the internet for. And so we'd often land at LAX and we'd actually sit on the tarmac for half an hour, maybe 2 hours, while they waited for a gate to open. Now, when we were on the tarmac, you could actually access Wi-Fi in LAX. And the first time I flew to the States in 2014, this is what I did when I tried to connect to Wi-Fi. So this is the Wi-Fi internet access for LAX, and it says, this page will redirect, so content doesn't really make sense to have here. And all of a sudden, I don't feel really safe about giving you my credit card details or logging into my bank account or accessing my email. So if there's one thing that you take away from this session, it's that you must test with real devices. There's just myriad of examples of people who have been testing on a big screen and you actually look at it on a mobile device, you can't read it at all. Or it's a location app and you find you're in one place and it won't actually tell you where you are or something along those lines. You must test with real devices. So the first thing we talked about was testing methods. So what testing methods are you going to use if you're going to test a mobile site or native app? For mobile sites, there are 4 main testing methods. So devices, which is testing on mobile and the tablet devices. and devices with assistive technologies, so testing on mobile and tablet devices with assistive technologies. Responsive window, there are some times where you can test on a responsively sized window on your desktop, and this can be useful because it can mean accessing the code and things like that, taking screenshots easier, etc. And then there is actually a requirement to test on a normally sized desktop window. It's really important to compare a website on the desktop to what it is on mobile. With native apps, although there are some testing tools out there, some of them are free, we weren't particularly impressed with any of them. So the methodology talks only about two main testing methods when it comes to native app testing: devices, which is testing on the mobile and tablet devices, and devices with assistive technologies, which is testing on the mobile and tablet devices with assistive technologies. So the actual methodology. The mobile site and the native app methodology are very similar with the exception of step 2. So there are 5 steps. Step 1 is identify devices. For the mobile site methodology, step 2 is identify site type and variations. Step 3 is test critical issues. Step 4 is test mobile specific issues. And step 5 is test mobile assistive technology and feature support. For native apps, it's exactly the same, except step 2 is define application functionality, and I'll talk about this in a moment. So let's start with identifying devices. The recommended devices and browser combinations are iPhone with Safari, iPad with Safari, and Android phone with Chrome. And we go into why we've chosen those and why we don't think, the Samsung internet browser is a good idea, etc. in the documentation. So have a look at that and, let us know what you think. You should consider, especially if it's a native app, you should consider testing with an Android tablet. And, if you're going to test a mobile site, make sure it's with Chrome again. And also consider testing with alternative devices such as a Kindle if you are testing an ebook, for example. In terms of versions, you should test on the latest version of iOS and the latest 2 versions of Android. Where a site is directly aimed at people with a particular kind of disability, consider including assistive technologies and or other assistive devices used by potential users. So if you have a site aimed at switch users, then you should really consider testing with the keyboard and switch options in your mobile and tablet devices. Just again, you need to meet WCAG 2 and this mobile testing methodology. So you can't just meet the mobile testing methodology and be accessible. You need to, make sure your headings are coded, your table headers have your tables have table headers, etc. The second step is to identify the site type and variations of the page in the mobile site methodology. So the first thing is to determine if the site is a desktop site, a responsive site, or an M.dot site. And if the site is responsive, are there variations of the page? Now, what do I mean? Desktop websites, they have only one display, whether they're viewed on desktop or mobile or tablet devices. M.dot sites have a particular display for mobile and tablet sites. The M.dot site must be tested across all of WCAG 2, and the WWW version needs to be tested against the mobile methodology as well. Don't assume just because there's an M.dot site that someone won't get to your www site on the mobile device. And responsive sites. This is much more likely to have a responsive site than any other site, and they change depending on the screen size or other feature as determined by the developer. So this is an example of a desktop site. This is the Australian National Botanic Gardens. You've got your navigation on the left, you've got a header, you've got a beautiful picture in the middle and some text. Now, this is viewed on a desktop. Now, if you make the screen size smaller by just dragging the edge of the window to the left, you find that nothing actually changes. You just cut off a whole lot of information, as if the information is underneath the scroll bar. That's a desktop site. In terms of an MDOT site, it's really important that you do these 3 steps. Ask the client if they have an MDOT site, but don't assume that if they say no, that that's the case, because I ran some training for Stanford, and we actually found a rogue MDOT Stanford site that no one knew actually existed. Then go to desktop and change the www to M and see what happens. And then compare the site on a desktop to the site on a mobile device and see if they're the same. So let's have a look at an MDOT site. So this is the Sephora website. You can see it's split into 4 sections. It's very brown. It's got nice pictures. It's got navigation along the top in a horizontal row. This is what it looks like on desktop. Now, if I replace www.sephora.com with m.sephora.com, this is what I see. The navigation is replaced with a hamburger menu. The search bar goes across the entire screen. There's no brown, there's only one image, it's very blue, etc. So very different sites. Now, if I look at these 2 sites on mobile, the left is the www site and the right is the mobile site. So you can see that, sorry, the MDOT site. The MDOT site is much more mobile friendly, but you can still get the desktop site on mobile. Okay, responsive websites. It's very likely that a site is responsive. If a site is responsive, it's definitely not a desktop site, but it's possible, unlikely, but possible, that there might also be an MDOT site. The site is responsive if the layout changes as you change the browser window size. To test this, open the website in a browser on your desktop. Ensure the window is not maximized. Select the right-hand edge and drag it to the center of the screen. And detailed instructions on how to do this is in the documentation. So this is an example of a responsive site. This is the Accessibility Oz website, and you can see that our navigation is horizontal across the top. We've got services, we've got 6 service icons by 1. Now, if we make that screen smaller, what you'll see is the navigation changes to a hamburger menu, and the services are now rows of 2 instead of a row of 6. And then if the site is responsive, you need to identify each variation of the page, because each variation needs to be tested. And it is important that all functionality is available on all variations of the page. And the documentation talks about this in a bit more detail. You can hide content so that it's, say, under an expandable menu, or it's on a different page or something like that. But you absolutely can't have one variation of the page that has less content and functionality than another variation of the page. Triggers for variation of the page could be the device. So, you know, they'll send something different to an iPhone versus to an Android. The operating system, so Windows versus iOS, for example. Browser, you know, Safari or IE Edge, etc. But the most common one is screen size, and that's where you see the low vision issue that we saw with YouTube. That is by far the most common trigger for a variation of a page, and under the methodology, it's the only valid way that you can trigger a variation of a page. And so moving on to native app, step 2 for native app is define application functionality. So basically, you need to really think about what your native app is doing. So a native app has much more kind of targeted functionality than, say, a mobile site. If you're looking at, say, the Wells Fargo mobile site, it'll have a store locator, it'll have a section on home loans, it'll have a section on opening a bank account, it might have a section on investor relations, etc., or even applying for a job. However, the Wells Fargo banking app isn't going to have a lot of those things. It will be specifically about maintaining your bank account, transferring money, checking balances, authorizing users, etc., etc. So that's what you need to really focus on. Ask the question, how would the experience be impacted if the functionality failed, the content could not be reached, or the experience caused a barrier to the user? Now, everything on a native app needs to be tested. However, in terms of prioritizing your testing, that's where you need to look at the critical functionality. And there are common elements on a lot of native apps that you just generally absolutely need to test. Things like navigation, landing screens, emergency sections, login flows, settings, accounts and profile, contact us, real-time updates, like for Uber or eBay or something like that, privacy policy, terms and conditions, interactional functionality, help section, widgets such as calendars, geolocational maps, high traffic areas, etc. And step 3 is test the critical issues. So we broke these out because these were really serious problems. What we found is that there are a lot more what we call traps in mobile sites and native apps than we found on desktop. So a trap is where a user is trapped within a component and can't escape without closing the browser or the app. An example on desktop would be a keyboard trap where you'll say tab into a video player and you can't tab out of it. And so the only way that a keyboard user can escape is to actually close the browser and start again. So we actually found quite a few new traps on mobile sites and native apps, and these are the ones we found. The first one is the exit trap. Ensure there is always an accessible, actionable item, e.g. a close button that meets color contrast requirements and has an accessible name, that closes any feature that overlays the current page, such as a full page ad. This applies to all users, and the methodology is both mobile site and native app. This is an example here. You're on Facebook and it throws up an ad at you, and there's no actual way to close that ad. So it's basically you're trapped and you have to close Facebook and start again. This here is the San Francisco Chronicle, and when you go to the website, it pulls up an ad with this tiny little close button that doesn't meet color contrast requirements. And so we would classify that as an exit trap because there will be some users who won't be able to see that close button and therefore won't be able to escape that trap. Then we have the swipe or scroll trap. It's so crappy, it's a scroll trap. Ensure you do not override standard mobile touch functions, swiping, scrolling, etc. on the majority of the page. This applies to touch users and mobile site and native app users. So this is an example. I've only seen this once, but basically if you scroll down to the bottom of the page, you can't scroll up. The only thing you can do is activate this little arrow in the bottom right-hand corner, and that throws you back to the top of the page. So that's an example of a swipe or a scroll trap. This is what I call the Zoom of Doom. So this is a map that takes up almost the entirety of the page, and the only way to actually scroll the page instead of the map is to hit these small areas of white around the side of the map. Now, a lot of maps now are doing this thing where, you have to use 2 fingers to scroll the map, 1 finger will scroll the page. That's great. So we're seeing that these things are improving. This is a very old example. A text-to-speech trap. If the app has an ability to provide content via text-to-speech, the screen reader user must be able to pause or stop the app speaking in a simple manner, e.g. by performing a swipe on a screen. This applies to screen reader users only, and the methodology is native app only. So this is an example of Pocket where you can tap and you can listen to an article, but once you've actually started listening to the article, there's no easy way for a screen reader user to pause the audio. And if they pause using the normal methods to pause the audio, it will pause their screen reader. It won't pause the text-to-speech, which is similar to a headset trap. Headset users must always be able to pause media, audio or video content by using the pause play control on the headset. This applies to screen reader users and headset users, and the methodology is mobile site and native app. So this is an example here where you go to a web page and at the bottom you have this little video that pops up and starts playing, and it has a little pause icon there, but you can only access that if you tap on it. If you pause using the headset, it pauses the screen reader. It doesn't pause the audio that's playing. And we have the layer trap. The user should not be trapped on a non-visible layer. This does apply to all users. However, it's mostly encountered by screen reader users, and its methodology is both mobile site and native app. And so this is an example here where you've got dispatch.com. When you open the hamburger menu pops out, but the screen reader is trapped on the layer underneath and will read the home page, won't actually be able to access any of the menu items. So let's see an example from the document. I've kind of reformatted it so it fits in a PowerPoint presentation, but I want to show you that you might go, oh, wow, this is a whole lot of information and I'm not sure if I understand all this, but there's a lot of information in the documents, examples, etc. So if you ever do look through stuff and information's not there, let us know, because they are working documents. So the one that I want to talk about are touch gestures. So the requirement in the methodology is any touch gesture must have an alternative, accessible, actionable item. For more information, see Success Criterion 2.5.1 pointer gestures. So it's very similar to WCAG 2.1. And if it's different, then we specify in the actual name how it's different. So examples of touch gestures are things like swiping up and down or left and right, dragging up and down or left and right, double tapping, tapping and holding, tapping and swiping, 2-pinch zoom, and press and long hold. Alternative accessible gestures must meet WCAG 2. They must meet change of state, touch targets, inactive space, native UI, and removal of touch. And those are all methodology, mobile methodology requirements, so you can look at those in detail. And some examples of alternative and accessible gestures are a link or a button or a drop down or a separate page with the same functionality. So, and then we have a section about this requirement. This requirement is particularly important for screen reader users. For example, if you require your user to swipe right to complete a purchase, when the screen reader is on, the swipe right gesture moves you to the next focusable item and doesn't complete the purchase. You must be able to perform the same action by using a link, an up and down swipe, or some other gesture. Please note that this requirement is similar to the exit trap requirement. However, a failure of the exit trap requirement is that a user cannot escape from the content or a page. A failure of the touch gestures requirement is that the user cannot choose content or a page, i.e. they're not trapped, but they can't proceed. And then we have a section that says how to test. Identify any site controls. If they require any of the following gestures, is there an accessible, actionable item provided as an alternative? And then it lists the gestures that you need to test. And so then we have an example here where the alternative is provided on another page. So this is weather.com, and you've got top stories, and you can see that as the second picture is cut off, that if you swipe from right to left, that you actually get additional stories. However, there's also a link at the bottom that says see more. And if you tap on that link, you get exactly the same content in an accessible way, so just vertically listed, as you would if you were swiping. This is another example where a tap alternative is provided instead of a drag gesture. So this is weather for Portland. Must have been in Portland when I was writing these examples. And basically at the section, when you want to determine, this is google.com weather, and you can drag the slider to determine what the weather is going to be at that particular time. However, and so that requires, of course, a drag gesture. However, if you tap on the actual time numbers instead, then you get the same information. So basically a link has been provided there. So then we have mobile specific issues, and they're broken into different sections like alternatives and display and actionable items. I'm just going to give you some examples, but all of them are very much detailed in the documentation. So alternatives. Alternatives are provided for geolocation functionality that is mandatory, for example, requiring a specific geolocation before functionality appears, unless the geolocation is essential for legal reasons or doing so would invalidate the activity. This applies to geolocation via GPS, user statement, IP address, or other methods. I must say, we spent hours arguing about Pokemon Go, and if, you know, you could play Pokemon Go as someone who was, say, in a wheelchair and couldn't go up a whole flight of stairs and things like that. So let me know what you think about that. So this here is IKEA in Australia, and I was accessing it when I was overseas, and it said, we want to access your location, and I was like, I don't want you to do that because I'm not in Australia. And so I blocked the location, and I get this error that says, info, location service is not enabled for this app. Please go to settings and enable it, limited functionality of app. Doesn't tell you what's not going to work, and it really shouldn't matter, you know, whether I'm actually located in that place or not. This is an example of a pass. This is Lyft. I was in Portland again, and as you can see, I'm located in the top here in northeast Portland, but I can actually set up Lyft to pick me up from a different location from where I'm currently located. And this is really important for, say, people who have carers that might be, you know, setting someone to pick them up or things like that. So to not force that the same location is where you're being picked up. Changes of state of non-standard controls, e.g. hamburger menus and star ratings, are clearly indicated. So this is the United app, and the hamburger menu, when it's closed, is a little hamburger menu, and its alt attribute is open menu. Well, not alt attribute, but you know what I mean. And when the menu is open, it actually changes state. It becomes a backwards arrow. It's not looking exactly the same. That's because it does a different thing now. It closes the menu, and the alternative text for that is close menu. Then we have display. Actionable items that have sufficient actionable items have sufficient inactive space between them. Inactive space of at least 10 pixels should be provided around active elements. So this is an example, it's one of my favorite examples. Edit and mark complete are right next to each other. It's very easy to mark something complete instead of editing it. And you know, there's not enough inactive space, but you really shouldn't have complete opposite actions that close together. Actionable items. Native UI controls, objects, alerts, and elements have been used. This is absolutely essential for native apps because, you know, native controls have inbuilt accessibility. And if you don't do it, you end up with something like this, where your expiration date seems to think it's a text field, has drop down of 14, 15, 16, 17, instead of just being a select box. You know, so much easier. When direct input via the keyboard is not required, provide options for the user to achieve the same results. I use a drop-down radio buttons and checkboxes. So this here is an example where it's prime now. The country is the United States, but you have to type in the state. Now that's just asking for mistakes. There's only 50 states in the United States. There's like 6 or 7, depending on who you ask in Australia. That should really be a drop-down. And so that's one of the methodology failures. This here is another example of doing it where you type in the address and it starts feeding through an auto drop down what that address should be, so you don't need to type it all in. Navigational aids. Visual indicators such as arrows, next and previous buttons have been used to indicate swipe or scroll areas or additional functionality. And this is very similar to 2.5.1 pointer gestures. So here, this is a BBC, and you're on the top stories. And if you swipe from right to left, you move to the My News. But there's no indication that that swipe is what's going to, you know, actually do that. Navigational aids such as back buttons, breadcrumbs, next and previous buttons have been provided. So this is also a failure of navigational aids. So basically, you know, this is iTunes on Android. I know, you know, why are you looking at iTunes on Android? But basically to close this, you actually swipe from the top to the bottom, but there's no indication that that's what you need to do. And in iTunes on iOS, there is. Audio and video. One of the things that we require is that all audio and video have a transcript. forms. Field labels are positioned adjacent to their input field and appear closest to their respective input fields in relation to other field labels and other input fields, which basically means don't do this, which is where you have yes, and then you have a radio button, and the radio button for yes is actually closer to the field label no than it is to yes. And then we need to test mobile desktop interaction. Of course, this is only for the mobile sites. Item labeling between different types of a site, desktop, MDOT, and responsive, and different variations of a responsive site is consistent. And so this is an example here of Asana, where on desktop, I would only operate using My Tasks, and on the mobile app, there is no My Tasks. And so now we use Trello. And then the last step is to test mobile assisted technology and feature support. Basically, there's just one requirement, but you need to test it on a whole bunch of different assisted technologies and mobile features. And that is all actionable items and important content can be accessed and activated by the following assisted technologies or when the following feature is enabled. And there are step-by-step instructions on how to use all these different features. So on iOS, we're talking about VoiceOver, keyboard and switch, zoom, invert colors, grayscale, and reader view. On Android, we're talking about talkback, keyboard and switch, magnification, invert colors, grayscale, increased text size, and simplified view. And if you're interested in learning more about these, the best place to find them is the Accessibility Oz website, and I'll show you now. So if you go to resources and then mobile testing, here we've got a little bit of introduction about WCAG 2, mobile versus native apps. And then we've got these documents for mobile site and documents for native app. So there are 5 documents for each type. The first one is the methodology itself. The second is about mobile site testing or about native app testing. So how you capture errors, site types, variations of the page, etc. Then we have the critical test cases, the mobile test cases, and the test cases for assistive technologies and mobile features. So please, I'd be really interested to know what you have to say about these. And we haven't convened a new committee for 2020 yet because of the whole COVID thing. And I was basically without internet for a couple of months, which was really painful. I thought 15 hours was hard. But we are going to be putting a committee together after the next ICT accessibility testing symposium, which is in a few weeks. So if you're interested, even if you don't know much about accessibility, but you know a lot about mobile, we really would like to hear from you. If you're a person with a disability or who uses an assistive technology or a specific feature, we'd love to have you on board. We meet for 2 hours every week, but don't worry, if you've got a very specific set of expertise, then we can just call on you and you can maybe review documents and things like that. So thank you very much. And I'm open for questions now.
Thank you, Gian. That was a great, informative and interesting talk. We have a few questions that we can go through. First question was from Mikola Trodnicki. And he was asking about how you would involve automated testing on things like mobile, Google Accessibility Scanner, or the Accessibility Inspector on iOS and Xcode with this methodology.
The methodology doesn't include the utilization of any automated testing tools. We didn't feel that they were certainly mobile site is a little bit different, but native apps, we didn't feel that they were mature enough to be included in the methodology. So basically the steps are manual steps. However, if a requirement can be done automatically, there's nothing stopping you doing a requirement automatically. We just haven't detailed it in the methodology.
Right. Another question. Is it ever sufficient to only test a responsive layout using the browser's developers tools and zooming, or should you always test on a physical device as well?
Absolutely, always test on a physical device. Always, 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 always.
Yeah, no, I agree with that. Here's a question from Adrian, who's busy currently preparing the next session, so I'll ask it for him. For testing on the latest version of iOS, given that the iPad OS is now distinct and might diverge from iOS, how long do you think before we need to fold in iPad OS testing as well as a separate part of it?
Excellent question. So in the methodology, when we released it, we said we haven't actually included the new features on iOS 13 because the methodology was finished in September or October, and the iOS 13 was released in September. So we say specifically that iOS 13 and the fact that there's going to be an iPad OS haven't been detailed in this methodology, but that's something that we'll be looking at in the next year.
Oh, great.
And one of the things that we'll be able to do is we'll actually be able to see what kind of differences there are and say, okay, you can get away with testing, you know, just on iOS, or, you know, if you have this certain functionality, you have to test on iPad OS.
Cool. Next question, it's a bit of a long one. So you mentioned that on desktop browsers, you know, zooming in will basically trigger responsive breakpoints. And you can see the content adapt, which kind of meets WCAG's requirements for reflowing content. On mobile browsers, however, pinch zooming doesn't really affect pages in any way, except that, you know, it blows it up really. Is there any kind of roadmap or planning for somehow making mobile browsers apply different media queries based on pinch zooming?
Wow, I don't have an answer to that.
Do you think it would be a good idea if they did plan that?
Yeah, so okay, when it comes to changing on mobile browsers, when it comes to changing text size, you're basically restricted to like the reader view or the simplified view. There's something inherent in the browser that allows you to increase text size, and it's not very, what's the word? It's not very reliable. It'll apply to some things rather than others, and you'll find boxes will overlap and underlap and things like that. So my answer is yes, I think that's an excellent idea. I have no idea if it's on anyone's roadmap, but I think that would be a great thing to do. Because
because we kind of look the other way when, sorry, go ahead.
Yeah, so like 15 years ago, maybe longer, they switched from, you know, basically triggering, you know, increasing the screen size. So from increasing just the text size. And there used to be massive problems with websites where you increase the text size and then the design just went all over the place. And then the browsers as a whole just changed and then decided to just make the, you know, the screen smaller, and it works so much better, and we very rarely came across accessibility, or not accessibility, but usability issues around that. So absolutely, I think the same thing would be right for mobile.
I think that's all the questions we had. I know that Thomas wanted to ask you which one is better, Apple or Google, but I think he's just trying to cause drama, so you can ignore that question.
I like that question. I like that question.
Unfair question.
Our developers say Android, but I personally, I'm an iOS fan. Yeah, I mean, look, because of this methodology, I've had to use Android phones a whole lot more than I would have ever had to use before. I feel that iPhones in general are just kind of more intuitive to use. And I know that's not necessarily seen as an accessibility thing, but I think that really goes a long way. I think that all of us, if we work in the IT industry, I think we take for granted how much we really kind of understand things and can figure things out. And I think the intuitiveness of the iPhone really means that it's a better phone for people with disabilities or people who are not in the IT industry.
Great. Well, thanks again for a great, useful talk. And we'll make sure that, is that the methodology currently publicly available that you showed us?
Yes, so that's on the Accessibility Oz website under resources, mobile testing.
Yeah, we'll make sure to tweet out that link and add it to the description of the video. So thank you very much, Gian.
Thank you.
Thank you. Excellent.
So yeah, we're going to move on to the next session soon. Just a quick reminder that Inclusive Design 24 is brought to you with thanks to Barclays Access, Adobe, Intopia, Tetralogical, InfoAxia, Intuit, WebAble, DQ Systems, and of course, Adrian Roselli, LLC. We're going to be back at the start of the next hour with Josh O'Connor, who's going to be talking about XR accessibility, and it's going to be very interesting, I think. See you then.